So today we're going to do something that is a little familiar, but we're going to introduce a couple other concepts as well. So we're going to deal with triangle similarity, but we're going to do a little proving in here, and there's a couple different ways that you can prove triangle similarity. Side, 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 angle, and angle similarity. So you could not do two angles to prove congruence. You could do side, 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 and side, angle, side, but you can use it in order to prove similarity. Alright, so just like we said a second ago, we have several ways to prove triangles are similar. Alright, we have side, 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 angle, side, and then we also have angle, angle similarity. So we'll start here and go through some rationale using this. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That's going to be enough to show they're similar. So take a second and jot that down. And then we'll go through and see how it's used. So we want to explain why the triangles are similar and write a similarity statement. Now you guys will see me use this more as a paragraph proof. You're kind of just putting some statements and reasons together. If you prefer to do a statements and a reasons column, if that feels more comfortable, that's fine. The main thing is you're getting all the information down and you're explaining why. Alright? So right here, we know that segment PT and segment SR are parallel. That's screaming alternate interior angles. So here's your transversal. That means that angle P and angle R are congruent. So let's go ahead and let's write that up. Angle P is congruent to angle R, and we know that because of our alternate interior angles theorem. Okay, now there's a couple different ways you guys can go with this. We also have this line parallel and this line is parallel. We have this transversal. Well, we can also say that angle T and angle S are congruent. Same reason. Angle T is congruent to angle S. By our alternate interior angles theorem. That's enough to show that we have triangle PTQ is similar to triangle RSQ. Take a second and double check and make sure that your angles match up, guys. Alright, your similarity statement, as we talked about in 7.1, has to be similar to a congruent statement. Alright, your angles have to match up. Now, another route you guys could have gone with this is you could have done one set of these angles, and then you could have used your vertical angles as well. And that would be perfectly fine. You don't need to show three, you're done by just showing your angle similarity. Let's write that up. By our angle similarity, you don't need all three angles. Okay, but if you prefer to use vertical angles, no problem at all. Okay, I wanted to show you all one other one that has a couple of blasts from the past in it, just so you guys can see it. So same thing, explain why they're similar. Now, I know immediately that angle B is congruent to angle E because they're both right angles. However, these guys are not congruent. But if I add these two together and subtract them from 180, I end up getting 47 degrees. Okay, well now I have two angles that are congruent. So let's write that up. By the triangle sum theorem, which is what I used, remember the triangle sum theorem tells you all three angles added together equal 180. Okay? By the triangle sum theorem, the measure of angle C is going to be 47 degrees. That allows me to say that angle C is congruent to angle F. And then I also know that angle B and angle E are congruent by the right angle congruence theorem. Again, something we used a lot of, but not in a while. And this is enough to say that triangle ABC is similar to triangle DEF by your angle similarity. Okay, so now we'll take a second and get these other two down. You have your side, side, side similarity. If three sides of one triangle are proportionate to the three corresponding sides of another, then the triangles are similar. So, you know, real familiar to your congruence. And we also have side, angle, side. If two sides are proportionate and their included angle is congruent, so these guys are proportionate and the included angle is congruent, and that's enough to show that they're similar as well. Alright, so let's go through and play around with these for a minute. We will do a couple proofs, nothing crazy. and call it a day. All right, so you want to verify that they're similar. Be careful. This one's not too bad, but this one has several triangles going on in it. So my suggestion is go ahead and let's draw these. We want to show that angle PQR. I'm going to label it to keep my head straight. Okay, so PQR is similar to angle PRS. Alright, so I oriented it a little bit differently. PS is 9, and PR and RS is 6. Okay, so we want to verify that they're similar. Now I can really see visually what's going on. Well, these are going to correspond. You know that PQ corresponds with PR, PQ corresponds with PR. Just do a quick check before you get down to business. Alright, so I know that 4/6 simplifies to 2/3. I also know that 4/6 here simplifies to 2/3. And I also know that 6/9 simplifies to 2/3. Therefore, I know that I'll write my similarity statement right here. I know that triangle PQR is similar to triangle PRS by side-side-side similarity. And this is all the work that you really need to show. Just show that the three sides are proportionate. All right, guys, I'm going to do the same thing with this one down here. This one's a little bit different, okay? So here, I want to do JKL. Here's your JKL right here. Let's get them down. And these sides are 2. Oh, and 3. Fix that really quickly. All right, and then I'm looking at JNN. All right, so this is going to be 6, and this is going to be 9. Okay, well, I don't have a third side, so I'm not going to use side. But I do know that angle J is congruent to angle J. There's your reflexive property right there. So let's write that up. Angle J is congruent to angle J by your reflexive property of congruence. And then I know that 2/6 simplifies to 1/3, and I know that 3/9 simplifies to 1/3. Therefore, I know that triangle JKL is similar to triangle JNN, and just be careful, by your side angle side similarity. So just kind of get used to those proportions, but again, this is really familiar stuff right there. Okay? So this is the last one here, guys. We'll go over and then we'll do a proof to end. So we want to explain why these guys are similar. All right, I'm looking at ABC and I'm looking at DBE. And you guys will probably see right off the bat that there's your alternate interior angles right there. I'm just going to use alternate interior angles because I think it's just a quick hit. And I know that angle C is congruent to angle E. And these are both by your alternate interior angles theorem. Alright, well that gives me enough to show that they are similar by your angle-angle similarity. And then now I just have to be careful. I want to find BE. So we're going to call that guy X. And looking at this, I know that AB coincides with DB. Alright, so 36/54 is going to equal BC, 54, over X, BE. Cross multiply, and you get X equals 81. The last thing we're going to do, guys, is a proof here. Alright, and you'll have a proof on some proofs in your homework, and you'll have a proof on your quiz. But it won't be anything crazy. It'll be stuff and reasons that you've seen several times before you do it. Alright, so this looks a little bit weird at first. Let's kind of go through and see how it's done. So here's your given right here. I know that 3UT equals 5RT. Okay, 3UT equals 5RT. Alright, so the ratio of this is going to be 5 to 3. Now, if I go through and I get my sides by themselves and my values by themselves, divide by RT, divide by 3, I get that similarity ratio is 5/3. This is your division property. Let's go ahead and let's write division property. like we've used it before instead of just saying the operation. We're going to do the same thing for this next piece. You guys can put this in one step if you prefer to do so. All right, here's your given, and then we're going to do the same thing. We're going to divide our sides, and we're going to divide our numbers. You'll notice that your similarity ratio is going to be the same. All right, so you have your two sides taken care of. Your RT and your VT have the same similarity ratio, and your ST and your VT have the same similarity ratio. I think I just said, I meant to say VT for this one. So I have these two sides. Well, then what do I need? I need to show this right here for your side angle side. And that's the last thing that we're going to write up. There's your vertical angles right there. RTS is going to be similar to VTU, or congruent, I'm sorry, by your vertical angles theorem. And then, here we go, we can write up our similarity statement right here. UVT is similar to RST. UVT, RST. Alright, so I'm going to skip over this one, guys. I have some weird stuff in there. We can talk about it tomorrow. And the last thing I want y'all to see, we're not really going to use these, to be honest, but we're probably going to reflect some other transitive properties. And we also dealt with that with our congruence. You can use these three properties in your similarity as well. However, we're going to do more using our vertical angles and our alternate interior angles in our proofs than we are these properties of similarity for the ones that we're going to do. So that's all I got, guys. This is what we're going to work on in class tomorrow, and we'll do a recap before class starts to go through it together.